Right now, while you're reading this, something is happening that almost nobody on Earth knows about. A machine the size of a small piano, weaker in power than the bulb in your fridge, is drifting away from your home at 38,000 miles an hour. Long after it should have died, and long after everyone who built it expected to still hear from it, it crossed a line written into the dark by the sun itself. The signal taking 22.5 hours to reach you right now is the only proof the line was crossed. If something is happening on the other side, only this little machine knows, and it has very little life left to tell us. This is the story of Voyager 1. If stories like this are why you came here, hit subscribe and turn on the bell, because what we are about to walk through is one of the strangest things our species has ever done, and it is not over yet. Let me take you back to the beginning. Not the beginning of Voyager, the beginning of the idea. The year is 1965. A graduate student comes up with a simple observation. The outer planets, the big ones, Jupiter, Saturn, Uranus, Neptune, were lining up in a way that would not happen again for 176 years. A window, a door, a chance. If you launched a spacecraft in the late 1970s, you could use the gravity of one planet to fling yourself to the next, and the next, and the next, like a cosmic billiards shot, except the balls were the size of worlds and the cue was just careful math. They called it the Grand Tour. It was beautiful because it was cheap. Using gravity was free, stealing a little from Jupiter to swing you harder toward Saturn, and a little from Saturn to swing you harder toward Uranus, and on and on. One launch. 4 planets for the price of 1. President Nixon approved the plan. Engineers started sketching what such a craft might look like. Smaller than a school bus, a big dish antenna on one side, a boom of sensitive instruments on the other, a plutonium power source because the sun would be too dim to power solar panels out past Mars. And then the budget people in Washington came along and canceled most of it. The Grand Tour got cut down. Uranus and Neptune got cut from the route. The original Voyager mission was just 2 spacecraft going to Jupiter and Saturn. 2 small ships, 2 chances. And the moment the first one left the planet, the second one was already behind it, 90 days behind, like a twin picking up the slack in case the older one died. Voyager 2 left first, aboard a Titan Centaur rocket on August 20th, 1977. Voyager 1 left 16 days later on September 5th, 1977. Yes, you read that right. The one called 2 launched first. The one called 1 launched second. And by the time Voyager 1 got to Jupiter in 1979, it found brand new moons. It found a ring around Jupiter no one had ever seen before. It found volcanoes erupting on Io, the small orange moon. Think about that. Volcanoes on another world. We saw them for the first time because of a piano-sized machine swinging past a planet nobody thought still had surprises. And then it kept going. It flung itself toward Saturn. It sent back the first close-up pictures of Titan, the strange orange moon wrapped in clouds we still do not fully understand. And it took a famous decision. The team on the ground chose to use Saturn's gravity to fling Voyager 1 upward, out of the flat disk where the planets live, not down toward Uranus like its sibling. Voyager 1 would become the first human object to leave the planetary plane and head for the deep. Voyager 2 would continue down to Uranus and Neptune and become the only spacecraft ever to visit those worlds. 2 ships, 2 paths, 2 different kinds of history. The most famous photograph in all of human history was taken on February 14th, 1990. Voyager 1 was 4 billion miles from the sun. The engineers turned the cameras around and pointed them back. They asked Carl Sagan, the famous astronomer, what picture he wanted. He said the Earth, just the Earth, a pale blue dot, a single pixel, a speck of dust suspended in a sunbeam. That is how small we are. That is the picture that still brings people to tears when they see it, because it is true. Every person they have ever loved, every war they have ever read about, every song they have ever heard, every prayer, all of it on a single dot of light. Voyager took that picture because someone thought to ask for it, because someone understood that being able to see yourself from the outside changes how you see yourself from the inside. And then something happened that almost nobody noticed at the time. Voyager 1 kept going, past Neptune, past Pluto's orbit, past the lonely cold where the planets thin out into the place the sun still owns, but barely, out into a giant bubble. And the bubble has a name, heliosphere. The sun does not just send light, it sends a wind, a constant stream of charged particles blowing outward in every direction, like a slow, silent snowstorm of protons and electrons, racing outward at 1,000,000 miles an hour. That wind pushes against the thin gas between the stars, which we call the interstellar medium. And where the solar wind runs out of strength, where it loses its fight against the stuff between the stars, there is a boundary, the heliopause. Not a wall you can see, not a line drawn in space with a marker, a region, a transition, where our sun stops being loud and the rest of the galaxy starts whispering. For decades, scientists argued about where Voyager 1 was relative to that boundary. They argued in papers. They argued in hallways. They argued in long, careful emails. Was it inside the bubble? Was it already outside? Some thought it had crossed in 2012. Some thought not until 2015. They waited for the data. The little spacecraft kept sipping its plutonium fuel and sending numbers home. And then in August 2012, the numbers changed. The solar wind particles around the spacecraft dropped almost to zero. At the same time, the cosmic rays from outside our solar system, the high-energy particles from ancient exploding stars in the galaxy, jumped up. Voyager 1 had crossed the heliopause. It had become the first human object in interstellar space. And here is the part that should make you stop and breathe. The signal from that crossing took 17 hours to reach Earth at the speed of light. 17 hours. The event already happened. We just had to wait for the news to arrive. We were watching the past. We still are. For a few years, that was the story. Voyager 1 was officially the first human thing to leave the sun's protective bubble, and it kept drifting, and it kept sending back data, and the world mostly moved on to the next shiny thing. New telescopes, new planets, new rovers. This is where the twist begins. In November 2019, the data started getting strange. Not slightly strange, loudly strange. The spacecraft was sending back the same pattern over and over. The pattern was a string of ones and zeros, like binary, but scrambled. Like the spacecraft was shouting the same word in a language we did not understand. Engineers traced the problem to a single chip on a single computer. The chip had failed. 22 hours away, the brain of Voyager 1 had broken. This was real danger. Not the dramatic danger of a movie explosion, the quiet, dangerous kind. The kind where one small part breaks and you cannot fix it because the fix would have to travel 1 billion miles. The team at NASA's Jet Propulsion Laboratory in Pasadena had to figure out how to put the computer's job onto another chunk of hardware, distantly by radio without breaking anything else. They tried. They failed. They tried again. For 5 months, almost every attempt failed. They could hear Voyager 1 was still alive, but they could not understand what it was saying. Then in April 2024, after years of trying, the team finally cracked it. They figured out a way to shove the broken code into a different part of the ship's computer memory. They patched the brain of a piano-sized machine, and that was almost 15 billion miles away. And Voyager started talking again. Real science data, real numbers. The heartbeat came back. But here's the part nobody tells you in the dramatic clips. The fix was a bandage, not a cure. The original chip is still broken. The patch is still in place, and the spacecraft keeps losing power every year. Its plutonium is decaying, slowly, quietly. Every clock on Voyager 1 is running out. By February 2025, NASA shut off one of the science instruments to save power. The cosmic ray subsystem, the tool that was counting the high-energy particles from distant exploding stars, went dark. By April 2026, another one followed. The low-energy charged particle instrument went silent. Today, in July 2026, Voyager 1 has only 2 working science instruments left on the entire spacecraft. 2 out of the handful it launched with. And the people watching it from Earth know that every decision now is a small funeral. Every switch flipped off is a sense the little ship will never get back. This is the clock running out. This is the countdown. A real one, not a fake one. A real one. And then, 3 months from now in November 2026, Voyager 1 will cross another line. A line no one expects a single human-made object to ever cross on its own. It will become the first spacecraft in history to be a full light day from the sun. A light day. The distance light travels in 24 full hours. It is a number so large that your brain will not hold it. Trust me on that. 12.4 billion miles on each side, 25 billion miles total, give or take. A signal sent from Voyager 1 at that distance would take a full day, traveling at the speed of light to reach home. Think about that. The little ship will cross the light day line almost 50 years after it left. And no other human thing has ever done that. Nothing we have ever built, nothing in our entire catalog, ever. But here's the part that is not being said loudly enough. When Voyager 1 crossed the heliopause in 2012, the story did not end the way scientists expected. They had a picture in their heads. Beyond the heliopause, the magnetic field was supposed to be calm, smooth, ordered, like turning off a fan and feeling the room settle. Instead, the magnetic field that Voyager 1 has been measuring out there is wild, distorted, twisting in directions nobody on Earth predicted. Teams at JPL wrote a paper about it. The paper is real. The numbers are real. The same numbers that came down, slowly, 22 hours at a time. And the conclusion is this. The space right outside our sun's bubble is not calm. It is busy. It is heated. It is full of structure nobody mapped. And the temperature Listen to this part carefully, because it sounds scary until you understand what it means. Beyond the heliopause, the thin gas of the galaxy is hot, wildly hot. Temperatures of tens of thousands of degrees. Some scientists call it the wall of fire. The language is dramatic, and that is on purpose, because real headlines need real hooks. But the truth is more interesting than the headline. The gas is so thin out there that the heat is almost meaningless to a solid object. A thermometer in that gas would register a wild number, but the feel of it would be less than a breath on a cold window. The wall of fire is real. The terror is not. What it tells us, what the Voyager numbers say, when you listen to them patiently, is this: the galaxy is not empty. The space between the stars is not nothing. It is a place. A real place, with weather, with structure, with hot regions, cold regions, magnetic rivers winding through it like curls of smoke, frozen in mid-air. Voyager 1 is sailing through that place right now in real time, sending back the first maps anyone has ever drawn of it. And there is more. Several years ago, the plasma wave instrument on Voyager heard something no instrument had ever picked up in that part of space. Weak plasma waves, tiny vibrations in the thin gas, like distant thunder, so faint it could be missed by any other ear. Voyager 1 caught it because Voyager 1 has the only ear close enough to listen. And now scientists are using those faint waves to estimate how dense the gas is out there. The first true measurements of the density of interstellar space, taken from inside that space by a machine smaller than a piano. Think about that for a quiet second. We have been guessing how thick the air is between the stars for a century, guessing from earthbound telescopes, guessing from theory, and now a 49-year-old spacecraft is measuring it directly. It is the only instrument we have ever had in the right place, and it is running out of power to listen. Here is the line no one expected, not a line drawn in space by a planet, not an edge made of rock or gas, a line drawn by time, a line drawn by the limits of human technology. Because in a few years, maybe by the early 2030s, maybe sooner, Voyager 1 will not have enough power to run even one instrument, and then it will not have enough power to point its antenna at Earth. And then it will go quiet. Not because it has been destroyed, not because it crashed into something. It will go quiet because its small plutonium heart will finally fade out. And after that, the little ship will keep drifting. Forever. Still moving at 38,000 miles an hour, still carrying the gold record with greetings in 59 human languages and music from a planet called Earth. But the line it just crossed is the last line anyone alive will ever hear it cross. After this one, every step forward is a step into permanent silence. That is the line no one expected. And almost nobody's talking about it that way. Now, some of you are thinking, so what? So a spacecraft runs out of power. So a thing built in the 1970s finally dies. Why does it affect me? Why does it matter to the air in my lungs, the water in my glass, the kid down the street? Here is why it matters. Because Voyager 1 is proof of something that almost every human being needs to be reminded of. That we are a species that does not give up on a question. That we are the kind of animal that builds a thing, sends it out, lets it fly for 50 years, and keeps listening. Not because we expect it to send back a treasure, because we are curious. Because curiosity is what we are. And the data it sends back matters because science is a slow-moving brick wall that someone has to keep laying. Every measurement is one brick. Every measurement is something no future scientist will ever have to repeat. Voyager 1 is laying bricks nobody else can lay because nobody else is out there. And when it stops, the wall stops growing in that direction, forever. Until the day, maybe 100 years from now, maybe 1,000, when another spacecraft flies the same path and resumes the count. If this kind of story is the kind of story you want to keep coming back to, subscribe now, because the next chapter of this is going to happen fast. November 2026 is on the calendar already. A date already locked in, the light day line, the first human object to cross it, and the team at JPL is already preparing for the moment when the signal takes a full 24 hours to reach home. They are already planning. They are already counting down. Now, here is the philosophical part, the part that may not sound like space and may sound like life. Voyager 1 was built in 1977 by people who are mostly retired now. Some of them are gone. The computer chip that ran the cameras has about 80,000 times less memory than the phone in your pocket today. The radio transmitter puts out about as much power as a refrigerator light. And it is still talking to us, in faint whispers, from further away than anything made by humans has ever been. That is the most extraordinary underdog story of our generation. Old, weak, small, cheap. Beating the odds in a way that should embarrass our newer, flashier machines. And the little ship is carrying a gold-plated copper record on its side. The Voyager Golden Record. A message in a bottle. It has greetings recorded in 59 human languages, including Akkadian, an ancient language that was being spoken 4,000 years before the record was made. It has a whale song. It has the sound of a kiss. It has thunder. It has the sounds of a human baby crying. It has music, Bach, Beethoven, Mozart, Chuck Berry. And it has the sound of a pulsar, a spinning dead star, encoding the position of Earth in space, so that whatever listens, if anything ever listens, can find the tiny blue dot the sound came from. Think about that. We do not know if anyone will ever play it. We do not know if intelligent life is out there. We do not know if the record will last longer than 10,000 years in interstellar dust. We do not know, and we sent it anyway, because the act of saying hello is itself the point. That is the bigger meaning underneath the facts. The universe is mostly empty. Most of it will never be touched by humans. Most of it is full of space we will never live in. And yet, on a small planet in a small solar system in an unremarkable spiral arm of an unremarkable galaxy, a few billion small soft beings looked up and decided, let us say hello. And the hello is still sailing outward right now, faster than a rifle bullet, slower than light, steady, patient, saying nothing but meaning it. And the best part is that Voyager is not alone. Voyager 2 is following, slower, but following. A New Horizons, which flew past Pluto in 2015, is on its way out next. And the interstellar probes of the next century will use better sails, better brains, better power. The hello will keep going, long after our names are forgotten, long after the phone in your pocket is a curiosity in a museum. But right now, only one of them is crossing a line no one expected. Only Voyager 1. And only for a short while longer. So tell me in the comments, what do you think Voyager 1 will find past the boundary it just crossed? What do you think lives out there in the wild magnetic weather beyond the sun's reach? Do you think anything will ever find the golden record and play it? I want to hear what you think, because the next moment of this belongs to all of us. Share this with somebody who has never thought about where the human race has sent its postcards from. They need to know this is happening. And thank you, genuinely, for staying until the end, for letting a 50-year-old spacecraft and a small story change the night a little bit. The line has been crossed, the clock is still ticking, and the view from here is closer than you think.